Hi guys, hope you're well. So today I'm going to be going through a year 12 AS exponential and logarithms question. This question is 4 marks. It's a proof type question. And I'm going to be showing you 2 ways of going through it. Now, if you would like to have a go at the question yourself, please pause the video and have a go. So let's get right into it. Now, the first thing I notice is that what we have to prove is in the form log. Log, if you didn't know, means log base 10. This is because log on its own is one of the most common bases there is. So whenever you see this log, you should instantly think log base 10. Okay. Next thing I notice is these values or answers inside the logarithms, 2 and 5. If we see in these equations, we have a 5, so that corresponds to that. We have a 4, but how does that relate to 2? Well, 4 is 2 squared. And same with this 10 over here. How does this 10 relate to 5 and 2? 10 is the same thing as 2 times 5. Now that I've established all of those connections, I can now start the question. This process I like to call reverse engineering. It's looking at our product, our end product, and trying to go backwards to see how we get to that starting point. So let's go. Let me write out the question. 4 to the power of x times 5 to the power of x minus 1 equals 10 to the power of x. 4 to the power of x is the same as 2 squared to the power of x. 5 to the power of x minus 1 equals 2 times 5 to the power of x. Now, using our indices laws, to get good at logarithms, you have to know your indices laws well because they both relate to each other. So this is the same thing as 2 to the power of 2x times 5 to the power of x minus 1 equals. Now, I will keep this as 2 times 5 to the power of x, like this. Next, I'm going to do what the question wants me to do, which is eventually get to logs. So let me take logs of both sides. Logs is an operator. It's like multiplication. It's like division. It's something I do to both sides of the equation. So log 2 to the power of 2x times 5 to the power of x minus 1 equals log 2 times 5. I'll put square brackets to emphasize that the power of x is to 2 times 5, the whole thing, like that. Now, this is where I can use my log laws to really simplify this process. Now, the two log laws in particular is the power law, which is k log base a of b is equivalent to, these three lines mean equivalent to log base a b to the power of k. So it's essentially multiplying by the power. That's the power law. Second one is log law of multiplication, which is log a of bm equals log base a of b plus log base a of m. So it's essentially when two values are being multiplied inside of a logarithm, you can split them up. That's essentially what the log law of multiplication is. So let's do that to both of these sides. As we notice, let's do the log law of multiplication to this left-hand side because we can clearly see it's being multiplied. So log 2 to the power of 2x plus, obviously using this law, log 5 to the power of x minus 1 equals log 2 times 5 x. Now I'm going to use this power law on all three. As we see, all three expressions have a power which I can multiply out. The reason why I'm doing this is because at the end of the day, the whole process is to get x on its own. All these powers essentially have x in it or contain an x. So we want this as a coefficient, so hopefully we can factorize and get x on its own. So let's use the power law. 2x log 2 plus x minus 1 log 5 equals x log 2 times 5. Now what I notice with this is, remember, this x minus 1 is being multiplied by log base 5. So using the distributive property of multiplication, I can multiply x by log base 5 and minus 1 by log base 5. So let me do that. 2x log 2 plus x log 5 subtract log 5. Minus 1 times log 5 is minus log 5 equals x log 2 times 5. Now I'm going to use, if you can see here, the value of the logarithms being multiplied. So I can use the log law of multiplication. Even if this coefficient is 2 or 3, I can still use the log law of multiplication. Let me give you an example. 2 log base 10 would equal, 3 log base 10 would equal 3 log base 5 plus 3 log base 2. If I had 6 log base 6 times 3, this would equal 6 log base 6 plus 6 log base 3. Now you can see that this is almost being distributed like this. The reason this is the case is, think of it like this. Let's say I had 9 log base 6 times 5. This is the same thing as 9 times log base 6 times 5. Now if we use the log law of additional multiplication on this, this would equal 9 log base 6 plus log base 5. Now what do you notice? I can expand this bracket out to get 9 log base 6, 9 log base 5. So this is why when I have this, for example, a coefficient in front, it's just basically me multiplying it out. So hopefully that makes sense into what I'm going to do for this step here when I'm going to use the log law of addition. So let me write out this next line. 2x log base 2 plus x log base 5 minus log base 5 equals x log base 2 plus x log base 5. Now I want x as the subject. So I'm going to move all the x terms to one side and anything that does not involve x to the other side. Hopefully you can see that involves this kind of process. Now let's do it. So 2x log base 2 plus x log base 5 subtract x log base 2 subtract x log base 5 equals log base 5. There we go. Now what you notice is x log base 5 minus x log base 5. That's like saying 2x minus 2x or 5 minus 5. They just cancel out. So these two here cancel out. So I'm going to write here, cancel out. Now 2x log 2 subtract x log 2. Log 2 is a constant. It's like a number. Log 10 of 2, that's a constant. So think of it like this. 2x times 5 subtract 2x. That's like saying 5 lots of a number, subtract 1 lots of a number. That's 4 lots of a number. That is the same principle here. It's like using multiplication. So 2 lots or 2x lots of log base 2 subtract x lots of log base 2 is just x log base 2. Hopefully that makes sense. And then these two cancel out, of course, which equals log base 5. Now I'm going to make x the subject. So I'm going to divide by log 2. And now let's compare. X equals log base 5 of 2. Yep. And that's all 4 marks. So hopefully through this first method, you can see the process we're using. The reason why I went through this method first is because I noticed log base 2 at the end and a 5 at the end. So I had to rewrite these two terms in terms of 2's and 5's. So hopefully that made sense. It's really about this first method, reverse engineering, looking at our end and trying to see how we got to there from the beginning. Now the second way I was going to show you is just the more standard algebraic logarithm method. Either way is fine. I just wanted to show you both for the purposes of this video. So the first step we can do is, instead of just waiting around, because we know this question is about logarithms, let's do that first. Let's take logs of both sides, log base 10 or just log, because they're the same thing. So log is equivalent to log base 10. That's what I mean. Equals log 10x. Okay. Next, what I want to do is use the log law of addition or log law of multiplication. Log 4 to the power of x plus log 5 to the power of x minus 1 equals log 10 to the x. So here, log law of multiplication. Next, what I'm going to do is use the power law on each of these three terms. Just like this previous step, here, when I use the power law in this step here, I'm going to do the exact same thing. So x log base 4 plus x minus 1, all brackets, because it's one continuous term, log 5 equals x log base 10. Because the 5 is being raised to the whole power of x minus 1. Okay. Next, multiply this part out. X log base 4 plus x log base 5. Subtract log base 5 equals x log base 10. Now move all the x terms to one side because we're trying to make x the subject. X log base 4 plus x log base 5. Subtract x log base 10 equals log base 5. Now we are going to factorize out the x. Log base 4 plus log base 5. Subtract log base 10. Log base 5. Next, use the log law of addition or multiplication. So simplify that. Log 20 subtract log 10. Now we're going to use the third law of logarithm, which is the log law of division. As you probably can tell, it's the inverse of the log law of multiplication. So with the log law of multiplication, it was like this. With the log law of division, instead of the value being multiplied, it's being divided, and that leads to not addition but subtraction. So you should try to relate these laws together for memory aids, is my opinion on this. It really helps you to establish